Hey everybody, this is Gregory from Dapp University, and today I'm going to show you how to build a fully decentralized application. And what I'm going to do is take the election decentralized application that I built on this channel, and we're going to take the client-side assets and make those distributed, those decentralized, with something called IPFS. And that's what we'll do in the video today. So if you haven't seen that tutorial already, feel free to check it out. I'll put a link down in the description below this video. And if you don't necessarily want to, follow along through that entire tutorial, it's a 2-hour tutorial, where I walk you through how to build the application step by step. You can download the code here on GitHub. I will also put a link to this down in the description below. So make sure you grab that to follow along with this video. And be sure to subscribe to the channel if you'd like to see more videos about how you can build decentralized applications on the Ethereum blockchain. So what does it mean for our decentralized application to be fully decentralized? And how is that different from the Dapp that we built in the previous tutorial? So in theory, if you're going to build a Dapp, a decentralized application, everything about it should be decentralized. And when we built the election tutorial, we built the contract layer of the application, the part that's deployed to the Ethereum blockchain, the code, in a decentralized way. It's essentially, the back end of our app. And the front end of our app, the client-side assets, we just developed those locally with a local development server, right? And most of the time, if you're going to deploy something like this, you would just deploy the client-side assets to a web server. And if you were to, run this in production, you would have, a Dapp that is on the Ethereum blockchain, but the client side really is just a traditional website, right? So we want to move away from that, and we want to move in a direction where our Dapp is decentralized. Because if our client assets are served off of a web server, then that really inherently is centralized, right? We want to move away from that and become fully decentralized. So how do we do that? If we can't serve our client-side assets off of a web server, then how do we serve them, right, in a decentralized way? We can't just upload, our image files and JavaScript files to the Ethereum blockchain, right? So that's where IPFS comes in. Now, if you don't know what IPFS is, you can go to ipfs.io to learn more about it. You can also go to the IPFS GitHub repository or the organization actually, and look at all of their repositories. This is the main IPFS repository here. You can browse through this. So essentially, IPFS is a distributed file system that you can connect to through a browser, right? So it's going to function a lot like our blockchain is. It'll also function a lot like, if you ever used a torrent or something like that, torrent protocol, it works somewhat like that. So essentially what this does is takes all of our files and serves them in a distributed way. So when we access our Dapp via a browser, we're no longer connecting to a central web server, but we are connecting to, a series of nodes that are connected to the IPFS network. A lot like our, blockchain Dapp. When we are connecting to the blockchain, we're not connecting to, a server where our app lives. We're connected to, a series of nodes that hold all the data in the Ethereum blockchain and, run the code of our Dapp, right? So that's what IPFS is, and that's how it works. So if you want to read more in depth about that, I just recommend browsing the website here. They got a lot of helpful information. We can they actually got a really good video. They've got some instructions about how you can get started, but you can also watch this video. It's a demo that gives a pretty good in-depth explanation. I won't go through all that here. Again, this is not really an in-depth tutorial on how to use IPFS, but I'm going to show you how you can get started pretty quickly deploying all the client-side assets of your decentralized application to IPFS. So let's go ahead and do that. I'm going to open my terminal. And let's just go ahead and take a look at the election Dapp that we're going to be deploying to IPFS. So in case you downloaded this from GitHub and haven't looked at the other tutorial yet, let's just go ahead and ensure that everything is running. So we'll do npm install all of our packages. We will start Ganache, ensure that Ganache is running. All right. And I will do truffle, migrate, reset, to migrate our contracts. All right. So our contracts are migrated. And the next thing I want to do is just start my development server. I will do that with npm run dev. Looks like our application loaded, and I'm going to just start MetaMask. All right, I'm going to connect to our local network. All right, so this is the election decentralized application that we built in the tutorial. Now you can see that this is running on a local server here. So this is a server that's essentially serving our assets, and this is what we want to move away from. We want to get our assets off of a server, right? We want all our HTML and CSS and JavaScript to move off of a server and onto a distributed file system that we can access, with a URL in our browser. All right, so that's what we're going to do. So let's go back to our terminal, and we will close this down for the time being. And the next thing that we need to do is actually install IPFS. So if you're on a Mac, you can use a package manager like Homebrew, or if you're on a different operating system or you want to use a different package manager, there's several different ways that you can install IPFS. You can just check those out on Google. So you would do that like this. Brew install IPFS. So I'm not actually going to do this because I've already installed it, but that's the first step that you would do. All right, so once you've got IPFS installed, let's think about, what are the components of IPFS and, what do we need to do in order to get our, files onto IPFS? So there are really kind of like 3 steps here. The first thing that we need is an IPFS node. Now this is kind of almost analogous to like, an Ethereum node. We need a process running locally that connects us to the network and actually serves our files, right? So that's the first thing that we'll need. And we do that pretty simply with IPFS init. This will initialize a new node. And I'm not going to run this because I've already done it, but that's what you would do first. And once you've initialized your node, you actually want to run it. You do that with this. IPFS daemon. We can see that it's starting. All right. And we can see that the gateway is listening and the daemon is ready. So I'm going to just tab over to a new tab to leave this running in the background. So right, we've got an IPFS node. That's going to be our node that's connected to the network. That's going to allow us to serve our files. And we've started this node. And now it's important to note, for the sake of this tutorial, you'll want to leave this node running in order to keep your files serving on the network. So if you turn it off, you won't be able to see it. So the next thing that we want to do is actually make a folder for our assets. So if we were going to look at the project structure of our Dapp, we can do ls, just L. We can see that we have a source directory. That's where all of our client-side application code lives. Actually, I'm just going to open this in Sublime Text. Yeah, somebody's asked me before, like what that subl command is, and that's just a symlink to open Sublime Text. So I'm basically saying open Sublime Text in the current directory. So if anyone's thrown off by that, that's what that does. So I'm opening this project in Sublime Text, and got a little message there. I'll show you the project structure here. So what we need to do is create a directory for all of our files that are going to be served on IPFS. So this is our source directory where all of our client-side code lives, right? We can see that we have, an index.html file. We have our JavaScript files. We have some fonts and CSS, right? So this is most of the files that we want to serve with IPFS, but we also need to serve our contract abstractions. So these are the contract abstractions here, these JSON files that have an ABI. This is an abstract binary interface. This is what allows the EVM to understand our contracts, but it also allows our library truffle contract to build an abstraction that can be used for our client-side assets. So when we make calls to our contract in JavaScript, we need these files to understand, the structure of our contract and all the functions that it responds to. And we also need to know the addresses of our contract based on the environment. And that's what this file also contains, that information. So we can see it has an address for this network, network 4. This is network ID of 4. This is the rinkeby test network. And 5777, this is our local network, and this is the address for the election contract locally. And these values were updated whenever I ran truffle migrate at the beginning of this tutorial. So just recap, basically what we need to do is create a folder for IPFS to put all of these files from source and all of these files in the contracts directory in the same folder. And we're going to kind of use this as our build folder or our distribution folder for our client-side assets. So that's exactly what we'll do. We'll create a folder called dist. It's kind of just a standard naming convention. And that's the folder that we'll use to put our assets onto IPFS. So I'll do that like this. I'll do mkdir or make directory. Dist. All right. You can see that I've created this new directory here. And I'm on a Mac, so I'm going to use the rsync command. And rsync is going to allow me to just create a copy of all the files from one directory and sync them to another directory. It's pretty handy. This is one I use a lot for building projects like this. So I'll do rsync -r recursive sync, source, and this. So what I did there was I synced all the files from our source directory where our assets are, I put them in the dist directory. And I'm also going to do rsync -r build contracts. I'm also going to put that in dist. All right. And then I'm going to lsl dist. And we can see that all of our files have been added to the dist directory. All of our asset files and all of our JSON files have been added to the root. We can also take a look at that in Sublime Text. If you're not quite as familiar at looking at the command line, we can just confirm that here. You can see that these files have been added. All right, so let's go back to our terminal. And now we need to add all the files from our dist folder to IPFS. And this is actually pretty easy. Well, actually, first, I'm sorry, I skipped a step. The first step is that we need to gather some peers that are actually going to share the content. And we do that like this. Do that with the swarm command. We swarm the peers. We can see some readout here. Now we need to add the files from our dist directory to IPFS. And that's pretty easy. We do that like this. IPFS, add -r, recursive, dist. All right. And you can see that all these files were added. Now we're going to take this last line here. You see where this says added, and it gives you a hash, and it gives dist. This is the hash for this entire directory. Like, we can see everything that was nested under this directory, but this is the actual directory that we want. So I'm going to copy this hash, and I'm going to publish this directory, right? This is going to be essentially like saying, if you were going to deploy a website manually, you would basically take the root directory of the website, and, you know, if you're using something really simple like FTP, you would just drag and drop the folder, you know, from your local computer to the web server. That would be, you know, kind of basic and simple. That's the idea. That's kind of what we're doing right here with IPFS. So we take the root directory of all of our assets, this dist directory. We're going to take the hash that corresponds to that, and we're going to publish it. So that's going to publish this directory to IPFS, and we'll get a URL that actually points to that directory, a lot like a web server. That's the whole thing with IPFS. It allows you to, you know, access distributed files through a web browser. So I'm going to take this hash and say IPFS, name, publish. I'm going to paste this hash in and click enter. Now this might take a second for you. It usually takes a second for me. And if we go over to our process, we can see that some activity is being logged here. I've been getting this error lately, and I did some Googling, and it seems like other people are also having this error, so don't be alarmed. I'm going to tab back over here and wait for this to finish. All right, so now that's finished. So what we can do, now that our files are published, we can actually access this directory that's published on IPFS through a web browser. And we do that like this. We take, you know, this hash that was that we pasted here when we added all of our files. We can see that this is published. And IPFS is going to give us, you know, a predictable URL that we can use to point to this hash or this directory on the network. So I'm going to go back to Chrome, and I'm going to tab over here. Now this is sort of this is how we build our predictable URL to access our files on IPFS. So actually, I'm going to go back to the terminal and copy this whole thing. We can see there's a /IPFS, then /hash name. So let's go back here. This is gateway.ipfs.io, and I'm going to paste that value. So this is /IPFS, and then / the hash name of our directory. Hit enter. And there we go. We have our published site. Now, this is our fully decentralized application. Fully decentralized. So the back end of our application is built with smart contract, published to the Ethereum blockchain. And now the client-side application is not hosted on a web server anymore. It's hosted on a distributed network, IPFS. And we can see that it's reflecting our account that we're connected to. This is actually the account that's connected to our local network, our Ganache blockchain instance. But I've actually deployed this election smart contract to the Rinkeby test network. All right. So what we want to do is, now I have a video on this already. And I can link to that as well. I can show you how to, deploy your smart contracts to a test network to get them off of your computer, off your machine, onto a test net, so that you can have something that's running, in production out in the wild, so you can see how your contracts work. And that's really important, because you don't always want to just, try something locally and then push it to the main network. You want to try on a test network first. So I'm going to switch to the Rinkeby test network, and I have an account that's connected here. And we can see this is the instance of our smart contract connected on Rinkeby. This is the account that I have that's connected to Rinkeby as well, with some fake ether. You can see that here. And this is it. So this is our fully decentralized application deployed to real networks. So the back end is deployed to Rinkeby test network, and the front end is deployed to IPFS. Well, that's it, guys. That is a fully decentralized application. That's a real Dapp. So I hope you all enjoyed that. I hope you all found that helpful. If there's anything that I missed or you didn't understand, feel free to leave a comment down in the comment section below, and thumbs up the video if you liked it. And also be sure to subscribe to the channel if you'd like to see more videos about how you can build decentralized applications on the Ethereum blockchain. And until next time, thanks for watching Dapp University.